Hello everyone. Our subject for today is Mathematics 10, third quarter, week 2. I'm your teacher, Roel R. Rosales Jr. Our topic for today is all about fermentation. But before we proceed to our discussion, let's read our learning targets. I can identify fermentation of objects and solve problems involving fermentation. What is fermentation? A fermentation is an arrangement of all or part of a set of objects. We use fermentation formulas when order matters in the problem. The number of fermentations of n objects taking at all time is p quantity of n is equal to n factorial. But there are occasions that you may want to choose and order r elements out of a collection of n elements. We have the fermentation of n objects taking r at a time is denoted by p, the quantity of nr, where n pr is equal to n factorial over the quantity n minus r factorial. Various notations are used to represent the number of fermentations of set of n objects taking r at a time, denoted by npr, PNR, or PNR, and the most popular are NPR and the quantity of NR. Notice that the objects to be arranged are all distinct. Suppose some of the objects to be arranged are not distinct. That is, some are identical. We have the number of distinguishable fermentation P of n objects where p objects are alike, q objects are alike, r objects are alike, and so on, is p is equal to n factorial over p factorial, q factorial, r factorial, and so on. Permutations that occur by arranging objects in a circle are called circular fermentation. So, we have the fermentation of n objects arranged in a circle is p is equal to quantity minus 1 factorial. Previously, you learned that each possible arrangement is called a fermentation. You also learned how to perform the formula of fermentation. The total number of fermentations for the 5 letters is 5 factorial, where 5 times 4 times 3 times 2 times 1 is equal to 120. Example 2. There are 8 runners in a race. If all we are concerned with the first, second, and third place finishers, how many orders of finish are possible? Solution. The total possible orders of finish are 8p3 is equal to 8 factorial over the quantity 8 minus 3 factorial is equal to 8 times 7 times 6 times 5 factorial over 5 factorial is equal to 8 times 7 times 6 is equal to 360. Example 3. A dress shop owner has 8 new dresses that she wants to display in the window. If the display window has 5 mannequins, in how many ways can she dress them up? Solution. The total number of ways is 8p5 is equal to 8 factorial over the quantity 8 minus 5 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial is equal to 8 times 7 times 6 times 5 times 4 is equal to 6,720. Example 4. How many distinguishable fermentations can be made from the letters of the word Philippines? Solution. P is equal to 11 factorial over 3 factorial times 3 factorial is equal to 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial times 3 factorial is equal to 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 over 3 times 2 times 1 is equal to 6,652,800 over 6 is equal to 1,108,800. Example 5. How many ways can 7 different trees be planted in a circle? Solution. P is equal to 7 minus 1 factorial is equal to 6 factorial. Equals 6 times 5 times 4 times 3 times 2 times 1 is equal to 720. Thus, there is 720 different ways. Example 6. How many ways can the letters of the word intellectual be arranged so that the vowels always come together? Solution. The word intellectual has 12 letters. There are 7 letters such as N, T, L, L, C, T, L, but T occurs 2 times and L occurs 3 times. We have 7 factorial over 2 factorial times 3 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1 is equal to 5,040 over 12 is equal to 420. There are 5 vowels in the word intellectual, but letter E occurs 2 times. So, 5 factorial over 2 factorial is equal to 5 times 4 times 3 times 2 times 1 over 2 times 1 is equal to 120 over 2 is equal to 60. Hence, the required numbers of ways is 420 times 60 is equal to 25,200. Example 7. There are 4 different mathematics books and 5 different science books. In how many ways can the books be arranged on a shelf if A. There are no restrictions. B. Books of the same subject must be placed together. C. If they must be placed alternately. Solution. A. P is equal to 9 factorial is equal to 362,880. B. P is equal to 4 factorial times 5 factorial is equal to 2,880. P is equal to 2,880 times 2 factorial is equal to 5,760. C. P is equal to 5 factorial times 4 factorial is equal to 2,880. We multiply by 2 factorial because there are 2 different books, mathematics and science. So that's all for today. Thank you and have a good day.